This is the third of 4 training programs presenting the operation and maintenance of an air brake system. We will study the emergency and parking brake system components shown. But first, let's review Program 2, the service brake system. The E6 is 2 separate brake valves in a single housing operated by a single treadle. It receives air from 2 separate reservoirs in the system's primary and secondary circuits. The E6 treats the circuits independently and applies or releases either the front or rear brakes regardless of failure in either. Fastened to the push rod of the service brake actuators, the slack adjuster multiplies and converts linear force into a rotational force, or torque. This force rotates the brake camshaft, causing the brake shoes to contact the drum. With the ASA5 automatic slack adjuster, the drum-to-lining clearance is also adjusted upon brake application. To ensure timely release of the front or steering axle brakes, a quick release valve was added between the brake chamber and brake valve. The R12 relay valve speeds up the application and release of the rear brakes, ensuring that the front and rear brakes apply simultaneously. Brake application air that flows to the brake actuators or relay valve also enters the SL5 stoplight switch. There, an electrical circuit is completed, lighting the stoplights. Let's go on now to the emergency and parking system components, starting with double check valves, such as the Bendix DC4. A double check valve performs 2 operations. It directs airflow for specific functions, and it selects the higher pressure from either of 2 sources. Parking brakes, for instance, can be controlled from either the front or rear service reservoirs. The most common double check valve uses a shuttle contained in a guide which is installed in the body. The DC4 has 2 inlet ports and 1 delivery port. As air enters either inlet port, the moving shuttle responds to the pressure. It seals the port receiving the lower air pressure level. But the airflow continues out the delivery port. If the pressure levels reverse, the position of the shuttle will reverse. The shuttle never impedes the flow of air. Here's a service tip. With certain double check valves used where pressure differentials may be minimal, mount them horizontally for optimum performance. The next component to be considered in the brake system is a dash control valve. The driver has several dashboard controls available. PP, or push-pull valves, are manually operable on-off air control valves. Pushing the button in places it in the delivery position. Most are pressure sensitive, like this Bendix PP1. It consists of a control button, plunger, spring, inlet exhaust valve, and body. The body has 3 types of ports: supply, delivery, and exhaust. The PP1 is manually applied. If supplied pressure decreases to a specified minimum setting, usually 40 psi, the PP1 will automatically move to the exhaust position. The plunger pops out, releasing air through the exhaust port. Of course, pushing the plunger back into the applied position reactivates the control. But supply air pressure must be above 40 psi for it to stay in. The PP1 is available in a range of auto exhaust settings from 20 psi through 60 psi. In Part 2 of this series, we covered the rear axle spring brakes. We learned that they function as the service, parking, and emergency brakes. Let's review briefly. The service chamber has a pressure plate and a non-pressure plate with a rubber diaphragm between them. The return spring in the chamber holds the push plate and rod assembly against the non-pressure side of the diaphragm. With a brake application, air pressure enters, ballooning the diaphragm and forcing the push rod and push plate out of the chamber. The return spring's resistance is overcome, and the brakes are thus applied. The spring brake acts as the service brake on the rear axle and performs the additional function of emergency and parking brake. The rear portion, sometimes called the piggyback, has a powerful spring, diaphragm, emergency piston, emergency air inlet port, and release bolt. During vehicle startup, air pressure is applied to the diaphragm. The spring compresses, and the brakes are held in the released position until the vehicle is parked or a system failure occurs. The two sections of the spring brake utilize air pressure in an opposite manner. Air into the spring brake section releases the brakes. Air taken away applies them. Here's another service tip. The spring brake release bolt mechanically cages the parking brake spring when air pressure is not available, so you can dismantle the brake or tow a vehicle. To ensure that the spring brake portion of the spring brakes respond quickly, a relay valve is mounted at the rear of the vehicle, near the brakes it serves. The relay valve speeds the application and release of the spring brakes. A spring brake relay valve delivers or releases air to the spring brakes in response to control air received from the PP1 push-pull valve or other source. A different relay valve controls the service brakes. The Bendix R14 relay valve is essentially the R12 discussed in Part 2 of this series. The lower half of both valves are interchangeable. The R14 has an additional anti-compounding feature built in. The components for the anti-compounding feature are contained in the cover and consist of a diaphragm and balance port. Anti-compounding, simply defined, means the avoidance of double braking. It prevents the simultaneous application of service brakes and emergency or parking brakes. The compounding of spring force and air pressure creates too much force that could possibly damage brake components. The R14 prevents this from occurring. To accomplish this, a line is connected from the delivery side of the service relay valve to the balance port of the R14. With no air pressure at the service port of the R14, the parking brakes are applied. If a service brake application is made, air from the R12 relay valve enters the balance port of the R14's quick release. The diaphragm moves, blocking the service port. Air from the balance port flows into the cavity above the relay piston, forces the piston down, opening the inlet, delivering air to the spring brake cavity. The R14, through its anti-compounding feature, assures that the parking brakes are released with the same amount of air pressure as the R12 is delivering to the service brake. The next component in the system is the optional SR1 spring brake valve. It's most often used on longer wheelbase vehicles, but can be used on tractors and straight trucks. Its primary function is to maintain modulated rear axle braking if primary reservoir air pressure is lost. Modulation takes place through the service foot brake, taking advantage of a driver's natural reactions in an emergency. In a rear axle brake system failure, the SR1 modulates the pressure delivered to the rear axle spring brakes in direct proportion to the amount of pressure delivered to the front axle brakes. The SR1 has 4 ports: the number 1 reservoir port connected to the rear axle reservoir, the control port connected to the front axle delivery circuit of the dual foot valve, a supply port to the delivery of the PP1, and a delivery port to the control of the R14 relay valve supplying air to the spring brake cavities. Inside, the SR1 contains 2 pistons. We'll call them piston A and B. Below each piston is an inlet exhaust valve, and above are the springs. The final component is a single check valve. As soon as air pressure starts to build in the rear axle service reservoir, it is also present at the underside of piston A, which is held all the way down with spring force. Its exhaust is sealed, and its inlet is open. As air pressure in the primary reservoir reaches 55 psi, enough pressure is also under piston A to move it up against the spring force. When the piston moves up, the inlet valve seats itself. Continued movement upward unseats the exhaust. As the system continues to charge up to 120 psi, the driver may elect to release the spring brakes. Pushing in the PP1 control valve delivers air from the PP1 to the supply port of the SR1. Piston B, held down by spring force, seals off the exhaust and holds the inlet open. Air pressure from the PP1 enters the supply port, flows past the open inlet valve under piston B, and on to the spring brakes. When the air pressure going to the spring brakes beneath piston B is about 95 psi, piston B rises slightly, closing the inlet, but not enough to open the exhaust. A balanced state is achieved. Both the exhaust and the inlet are closed. The spring brakes are released. The vehicle can be moved. A normal service brake application at this point has no effect on the SR1. Air flows to the front axle service brakes and to the control port of the SR1. It stops there because the inlet valve under piston A is closed. The rear axle brakes also apply normally using air pressure from the foot valve. The SR1 will not be affected by a front axle service brake failure. It monitors only rear axle service brake reservoir pressure. The spring brake will remain released because of the double check valve. The rear axle service reservoir will continue to supply air to the PP1, and the PP1 will continue to supply the SR1. If rear axle air pressure is lost, the driver will be warned, and the shuttle in the double check valve will move to allow the front axle reservoir to supply the R14 relay valve and the PP1. Even though air pressure for the spring brakes is shown in orange, the red front axle service reservoir is supplying the air pressure. However, as pressure drops in the rear axle reservoir, air pressure at the number 1 reservoir port of the SR1 drops, causing piston A to move down due to spring force, sealing the open exhaust passage, and with continued movement to unseat the inlet valve. When the driver receives a low-pressure warning and applies the brakes, only the front axle service pressure will be available. The front axle brakes apply normally, and the same air pressure is delivered to the control port of the SR1. The front axle application air will enter the control port, flow by the open inlet valve, and through the internal passage to the outer surface of piston B. The pressure there will cause piston B to rise, opening the exhaust valve. Air pressure in the spring brakes will be exhausted until the springs are allowed to achieve a balance, reducing the pressure under the inner diameter of piston B. As a specific example, if a 20 psi pressure application is made to the front axle brakes, 20 psi is delivered to the control port of the SR1. It represents a 20 psi control pressure and exhausts enough pressure from the spring brakes to simulate mechanically a 20 psi air application to the service side of the spring brakes. When the foot brake is released, the air pressure in the outer area of piston B is exhausted back through the foot valve. The springs above piston B move it down, opening the inlet, allowing air from the front service reservoir to flow through the double check valve, the PP1, the open inlet of the SR1, and into the spring brakes to recharge them. The spring brakes can be applied and released or modulated on and off about 5 times. Here's a service tip. The number of brake applications depends primarily on the severity of brake application, reservoir size, and degree of reservoir contamination. One reason to drain reservoirs regularly is that the volume of contamination reduces the volume of air available. The SR1's internal check valve assists the exhaust action from the spring brake. Piston B is in the balanced position when the spring brakes are released. The inlet exhaust valve beneath piston B is closed. The check valve is closed because of the spring force and the fact that the pressure beneath the check valve is slightly greater than the pressure above it. When the PP1 park control is put in the park position, air from beneath the inlet valve returns to the open exhaust of the PP1. The pressure above the check valve becomes greater than that below it. The check valve opens. This allows the spring brake hold-off pressure to also flow back to the open exhaust of the dash control. Pressure beneath piston B is then reduced. The springs above piston B can move the piston down, opening the inlet valve. This enlarges the path for air to return to the PP1 exhaust. When the air is completely exhausted, the vehicle parking brakes are fully applied. That concludes our presentation of the parking and emergency brake system. Let's review the devices briefly. The DC4 double check valve directs airflow to the PP1 from either of 2 reservoirs, whichever has the higher pressure. The manually operated push-pull PP1 moves from the applied to the exhaust position automatically when supply pressure reaches a designated minimum. Spring brakes and chambers convert air pressure energy to mechanical force to apply the brakes. Relay valves speed up the application and releases of brakes, particularly the rear axle brakes. In dual brake systems, the SR1 spring brake valve supplies a limited hold-off pressure to the spring brakes and causes a mechanical application of the rear brakes if there is a loss of rear axle service pressure. The first 3 parts of this series have covered a complete air brake system used on a typical straight truck or bus. Part 4 will present the additional components unique to an air brake tractor and the components necessary in a trailer system. We hope we have increased your understanding of the parking and emergency brake system and its components. For more information and a complete Bendix service manual, contact your local authorized Bendix parts outlet.